Welcome to this lesson. I'm writing a program that captures screenshots. My name is Blake Jacobs and I'm an educator at MCSI Cybersecurity Institutes. Now, what we have to perform or complete in order for this lesson to be a successful pass are the following actions. A program that runs in the background and is invisible, either through a process or a service of some sort. A program that takes screenshots every minute, so we need like some sort of ticker that when the function gets called every minute, it will take a screenshot. A program that starts up on boot time, we'll cover that later because it's something we have to cover through the PowerPoint. And screenshots are hidden and files are stored in hidden folders on disk. So the files need to be hidden and they need to be stored in hidden folders on disk. Now screenshots are compressed to reduce the amount of space the files have on disk. And also what we're going to be doing in this lesson, because it's a coding exercise, it's a routine one, I'm going to be showing you this exercise with Go language. I know Go language really well and I find it's a very useful language, easy to understand and very good. And also down the bottom here, there is actually a library that helps with screenshotting in Go language, because you realistically don't want to write your own package or your own library to take screenshots, because that would take a while. There's already packages out there to make that an easier process. So let's go to our PowerPoint. So here's the PowerPoint on how to write a program that captures screenshots. So let's have a look at the agenda. So this is what their agenda is. What it means for malware to start on boot time. This is what the agenda is. Why write malware to run in the background? What information can be obtained from capturing screenshots? What can an attacker do with the discovered information to the target organization? And then we're going to go through a technical demonstration, which will be based on, code, and I'll be showing you some packages and some pseudocode to understand how to write this program. And then that will be the end of the lesson. Let's look at number one. So what it means for malware to start on boot time. So an attacker will also want the malware to stay persistent on the system, meaning it will remain on the system for as long as the attacker desires until he or she is done with the malware, and then they'll remove the malware and cover their tracks by removing any traces. So they might want to upload a bit of malware through either the victim might either download it from a website, or it might be uploaded through an exploit, and then it stays on there persistently until the attacker doesn't want it anymore. Then they remove it and then they cover their tracks. So the covering tracks is very important because they don't want any people to find out. They don't want say forensics investigators or people just don't want anyone to find out that it's been there. Now, why run malware in the background? Now, the attacker will need a way for the malware to run in the background as a service or process so it stays hidden, leaving the victim completely oblivious that the malware is even on the system. So if you've got this window that's popped up and it stays there, then they're just going to close it and they're going to go, oh, that looks a bit sketchy, and then just going to close it. So it needs to sort of pop up and hide, or just hide straight away and stay hidden, or even as a service or process. Only thing with a process is they can end a task. With a service, it stops and starts on the computer load. When the computer loads, so they can stop the service, but then it might restart later on in a specific time, or it might have an interval when it starts, or it might even just be as simple as it loads when the computer loads up. So that's what we're going to be covering in the coding exercise. So what information can be obtained from capturing screenshots? This is very cool because images contain EXIF data or EXIF data, which stands for exchangeable image file format, and they store information such as GPS coordinates, hardware used, pixel ratio, and things like that. So if you've captured a photo on taking a photo with the camera on the phone, if your location services are turned on, it will store the GPS coordinates inside that image, which is in the exchangeable image format. So this can be actually extracted using certain tools with Python and other tools to get the GPS coordinates and locate where the victim is. Now, not so much images that are screenshotted on computers, because usually have software that we want you to create to take screenshots every minute. So that's not going to necessarily have GPS coordinates. But what is most important is An attacker may also want to map out what antivirus solutions they're using for a potential bypass. So the screenshot that is captured, it will show you if they're looking around on the computer and they're looking out and they're maybe looking around in the taskbar, and you might find, there might be an image and it might have, AVG, or it might have Nord or in Norton, or might have these different antivirus solutions that we might then investigate and find out how to create a bypass for that. You might want to upload a backdoor to the machine that bypasses the antivirus solutions through code mutation, any of those sort of techniques to bypass antivirus solutions. Go language is very good for bypassing antivirus solutions too. They might want to have a look to see what websites they visit or software they used, IP addresses, architecture, the operating system. So we could figure out a potentially, with all the software we can find out and exploit. This can be all used through screenshotting and can be used to carry out further attacks. What can an attacker do with the discovered information to the target organization? Well, with all this information they have collected through screenshotting, they could find what software is out of date to exploit their system. So they may want to find a 0-day or even upload malware that can bypass the antivirus solutions. Or they may want to use a keylogger to capture passwords and etc. So let's go over a technical demonstration. Now, first of all, I want to show you a diagram of how this attack might work. So let's get Paint up. And let's have a look. So we have the victim's computer, which is, say, right here. And then we have the attacker's computer, which is right here. And we'll paint this in, say, red for the attacker. And what's going to happen is this attacker is going to exploit a vulnerability on the system. So he exploits either a vulnerability and gains access to the victim's machine. So he gains access to this, gained access. And he's now affected by, he's now exploited. Now what's going to happen is the victim is going to, the attacker is going to exploit, it's going to upload some malware. I'll just put that black. It's going to upload some malware. It needs to be a little bit thicker. Just wait, I need to get this right. So it's going to upload some malware on the machine. So this will be screenshotting malware. So uploads screenshotting malware. And what happens is it takes some screenshots every minute, and what happens is that attacker will remotely fetch those, remotely download those, so he can then see what's going on. So he can then have a look, so he can look and gather intelligence. And that's pretty much how it works. It can be either through an exploit, it can be through their victim downloading malicious software from a server, or it could just be through them physically accessing the machine and uploading malware. So let's now move on to some coding exercises in pseudocode to help you understand how to program this. This pseudocode right here, and this pseudocode is screenshot malware, and this is what we kind of want you. This is what we want you to write. But this is pseudocode, so this actually has no valid syntax. It's not a valid language. It's just to prove it's just to sort of get the point across and show you what you need to be able to do, what you need to do for this to work. So back at this lesson, the platform, it has this Go library. So this screenshot library is what we want you to use. It will be very useful to, and this even has like an example code here for taking screenshots. But we want it, if you don't want just that, we want you to implement a feature that will create like a timer or a tick. So every time the timer starts and every time a minute is passed, it will call a function and it will screenshot. But we also want you to hide the files, and we also want you to make it start up when the computer starts up. So here's this example of pseudocode. Let me run through the code and show you what it means. So this is our package main. We always start in Go languages in a line called package and then the package name. So example main, it could be anything. And then we import our modules. This is the proper syntax to import modules, but except modules would be replaced in there. So you might have module 1, right, for example, you might have this module here, right there. So you put that in there. And then the next one might be something like OS. So you put a space and you put OS. That's how you do import libraries on packages. But we're not going to go through that. Then you have your main function. This is like where the first function that gets called. This is the function that gets called every time the program starts. And what I've done here is this not valid syntax pseudocode is I'm taking a screenshot every minute. So what's happened is it's iterating and it's having a time that ticks. So once the minute is passed, it will call our snap screenshot function, and it will go down here, and it will get the number of active displays. So there might be 2 display monitors, there might be 3. So we want to capture all 3 of those monitors, the images on all 3 of those monitors. And what's it doing here is it's actually it's creating a for loop, and it's it's iterating through all the number of displays, and it's getting the bounds of the display. So if it's like 1920 by 1920 by 1080 or something like that, it's getting the rectangle around the screen. It's getting the size of the screen, and then what's happening is it's capturing the rect, which is it's capturing it's basically calculating how big the image should be. And then if there's an error, it will just return the error. And then it's getting the file name for us. So we're going to have a file name that is in the format of the date and the image. So the number. So it will be like either 1 or 2, and then we'll have the screenshot size as the name and a .png. Then it will create the file name, and then it will encode it, because this library comes with an encoding method that will help us encode the image for compression and less space. And what happens is after it does all that, it will hide the file. So there's some pseudocode for hiding a file, and there's also a really good blog on Stack Overflow that will help you understand that too, just as a matter of a Google search. And what happens, it checks to see if the operating system is Windows, and then it will create a syscall, which is getting the file name from the path, and then it will reference I think a pointer. So it's UTF-1 pointer from string. So it's creating a pointer with the file name, and then it's setting the file attribute. So we need to set the file attribute to hidden, so the file is hidden. This is the most important part of hiding a file in Go language. Now this can be done just through a Google search. I looked at this in Google, and this is how you could find it too. And then you just check to see if there's an error. If not, then it will return, and then it will return nil if it reaches this block of code here. That's pretty much all you need. And again, you can just search for, hiding files with Go. If I can type Go language, and that will show you how to do it. So for example, this one here is what I looked at, and this is what you could find. And apart from starting up when the malware when the computer starts up, again, search on Google. It's your friend. There's also another library there that will help you. Also, you can say Go language or Go program starts on boot, and again, there's a library that you have to play around with. Right there, Go auto start is a good library to play around with that will help you do what is needed for this exercise. I'm not going to show you, but there's actually this XXC. This is a struct. Autostart.app is a struct, and it contains different variables. And this is the name of the AutoStart app, and it's a display name, and this is an execute. So this is what gets executed when the program, the operating system logs in. So again, play around with that as well. This is really useful. Yeah, that's pretty much it. I guess we want you to also hide the files in a hidden folder. So again, you can create a folder on the desktop, and again, you can look up this on Google. Just say we created that, and we can go to for our properties, right click and go to properties and make it hidden. So when we go hide, and again we can go to, that's going to be hidden, but again we can go to here, go to view, options, and go do not show hidden files, and that will completely hide the file right there. Won't even know it's there. See, doesn't even know it's there. But again, you want to do this programmatically, so I recommend you looking up how to do this programmatically, okay? Okay, so another thing we need to do is hide the application from the victim. So they are completely oblivious, it doesn't even exist on the computer. So in order to do that, we need to use these LD flags. So we can actually go to these look at the linking properties on Go language. So here are the linking properties, and as you can see, you look at all these, and it will tell you how to hide the application. Now I recommend you have a look at all these and figure it out yourself. But in here will be a way to hide the application. So it's actually not visible from the victim. So have a look at the linking properties. These are all linking arguments and properties, and in there will be a way to actually hide the application. So yeah, that's about it for this exercise. I hope you do really well, and thank you for being a big part of the community. You guys are legends. You're doing so well. A big ever-growing field in IT security. Keep at it. Keep being passionate. Keep learning these skills, and you will master the field. So cheers, and catch you later. Bye bye.